Now, hello students. Today we are going to learn about the flip-flop. It's a second chapter of paper 1 unit 3. Now, within this chapter we are going through the RS flip-flop, D flip-flop, JK flip-flop, D flip-flop and master and slave flip-flop. RS flip-flop. As the figure shows, the RS flip-flop using the NOR gate. The two NOR gates are connected in a cross-coupled manner such that the output of one flip-flop is fed as an input to the other. R and S are both inputs of the flip-flop. R stands for the reset of the flip-flop and due to which the output appear to be 0. Whereas S stand for set. It means that when S equal to 1, it is stored Q equal to 1. Now, as the figure show you, if I keep S equal to 0 and R equal to 0, case 1, since both the inputs of NOR gates are 0 and has no effect at the output, the latch remains in a present state as before it was. That means Q remains as it is before Q bar also remains as it is before. This operation is called hold or no change operation of RS flip-flop. Second case, if S equal to 1 and R equal to 0, this forces the NOR gate of second to be a low, and both the inputs of the NOR gate are then for the first one is low, that resulted into the high output Q1. Okay, and this is called the set operation of RS flip-flop. If S equal to 0 and R equal to 1, S equal to 0 and R equal to 1, this forces the output of NOR gate as a 1 over here, and that is why the second NOR gate has both the input as a high, which resulted into output as a 0, and therefore the Q remains 0. This operation is known as a reset operation of RS flip-flop. Now, well, basically, I speak about the latch. What is latch? Latch is a bistable device capable of staying either of two states, that is set and reset, for indefined time period. The latch are similar to the flip-flop, only they are differ in the modes of changing their state. If enable is of input of latch is low, the output of latch should be hold its previous stage. And if the enable input of the latch is high, the output latch change depending upon the inputs it has right now. When the flip-flop triggered, by either positive edge or negative edge of the clock, the there is a change in the state of the output. Now, when S and R both are input in the following SRERS flip-flop, the latch will not operate properly, and therefore it is not desirable to have both S and R equal to 1, as Q and P both are not complement to each other when S and R both are equal to it. If S and R change to 0, 0, the network will oscillate, assuming that both the gate have the same delay. It is a critical race around condition and not permitted in RS flip-flop. Now, as I speak just before the latch with the flip-flop, A flip-flop will remain in one of the two states indefinitely until the sum of external trigger pulse is applied to make it change. That is what we call enable pin. Now, if enable stands 0, no matter what you are providing on the inputs of S and R, the output remains unchanged. But when the enable is activated, and that is means we have put 1, then the whatever the condition upon the input, according to that the output will change its state. For example, if S and R both are 0, it remains unchanged condition in SR flip flop. Therefore Q and Q bar remains same. But when S equal to 0 and R equal to 1, Q equal to 0 and the Q bar equal to 1, this is the reset condition of SR flip-flop. When S equal to 1, R equal to 0, Q equal to 1 and Q bar equal to 0, that is the set condition of RS flip-flop. When both are 1, again this is not a defined condition. We should not be put S equal to 1 and R equal to 0. That is the undesirable forbidden condition for the RS flip-flop. Now, with this help of RS flip-flop, we can design D-type flip-flop. The D-type flip-flop is also known as a data latch and has only one input, that is referred to be as a D, and the data input. When the pulse clock appeared, the whatever the input is there will appear at the output. This is what we have a D-type flip-flop. It's a very simple flip-flop. In a RS flip-flop, there is a smallest change. You have put a NOT gate, inverted gate between S and R flip-flop. That means no change condition or race around condition will be not appeared for the RS flip-flop. Now, if D equal to 0, that means we put D over here as a 0, data line as a 0. Automatically, one terminal of RS flip-flop is 0, other terminal of RS flip-flop becomes 1. Since D equal to 0, we will reset the flip-flop and it remains Q equal to 0. When D equal to 1, that will result into the Q equal to 1. As D equal to 1, that means S equal to 1, and complement of this, that is R equal to 0. Therefore the flip-flop will set, and this is what we call as a set flip-flop. That means whatever the input we are providing will be appeared at the output, depends upon the clock input we are giving to this. The D-type flip-flop transfer its digital data between input and its output after a delay of one clock pulse. So the D flip-flop is also referred as a delay input flip-flop. Now, according to the agenda, next flip-flop which we are going to see is the JK flip-flop. Now, JK flip-flop is very much similar to the RS flip-flop which we have previously studied. Now, most popular commonly used flip-flop is the JK flip-flop. In this flip-flop, the RS flip-flops states, just as for example, forbidden or race around condition will be eliminated in the JK flip-flop. By converting the RS flip-flop into the JK flip-flop, one way is to make the universal flip-flop. Therefore, RS flip-flop is considered to be as a universal device. Now you can see over here the RS flip-flop has been converted into JK flip-flop by adding two AND gates, and these two AND gates has three terminal. One is J, another is K, and one is second terminal is clock, and the third one is actually the complement of output. If J and K both input are kept high logically, then the Q output will remain the toggle state. That means it will change the state every time the clock appear. Whatever toggle, that means if it is 0 and 1 step before, if Q bar is 0 and Q is 1, then it will change the state to 1 and 0. ठीक है ना, the output will remain unstable, creating a race round condition has been eliminated in JK flip flop, which is a conversion state of RS flip flop. ठीक है ना, we can see if J is 0 and K is 0, both are 0, still we will have the same 0 appear to be at the NAND gate as AND gate, as any input 0 in AND gate will give the output as 0. We know any input of AND gate is 0, then the output is 0. This is the what statement of the AND gate. Okay, since J is 0, the first AND gate will provide you output as a 0, and K is 0 will provide the output as a 0, which is 0 0 condition for RS flip flop, and that is no change condition for the RS flip flop. Therefore, the latch remains as it is. That means it will show the previous condition. When J is 0, K is 1. Since J is 0, the first AND gate will provide you output as a 0, and since the K is 1, the second output of second AND gate will second AND gate will provide output as a 1. This 1 is provided to the reset condition of RS flip flop, that is R input of the RS flip flop. Therefore, Q will become 0 and Q bar will become 1. Now, if J is 1 and K is 0, since K is 0, the second AND gate will provide you output as a 0, because any input of AND gate is 0, the output remains 0. Now, since J is 1, the first AND gate will provide you output as a 1, and this 1 is fed to the S input of RS flip flop, that means set input, and due to which the Q will set and you will get the set output, that is Q equal to 1 and Q bar equal to 0. As for both J and K are 1, both the input of the AND gate will toggle every time, and due to which the output, and this time the input to the JK flip flop will depend upon the output condition of previous state, and that will toggle the state of the RS flip flop. That means RS flip flop will never go into the forbidden condition, it will toggle every time the flip flop will appear. Now, with this JK flip-flop, we can design one more new type of flip-flop, that is called toggle flip-flop. In toggle flip-flop, it has a single input, that is T-type input. It is similar operation of D-type flip-flop. Only difference that we are connecting both J and K input to the 1, logic 1, and due to which the toggle state will appear at the output at every next clock cycle. Therefore, it is called toggle flip-flop, because J and K both inputs are kept 1. Every time the pulse appear, the output will toggle the state. Next, we have a master and slave flip-flop. Now, master and slave flip-flop are made up with the JK flip-flop. Now, in this flip-flop, first is a JK flip-flop. First JK flip-flop is known as a master latch, and second JK flip-flop is known as slave latch. Both the JK flip-flops are combined with each other with the help of a clock, because of clock at the master is appear on the rising edge, whereas the clock inverted and given to the slave latch, which appear at the falling edge. Now, with this, That means the basic concept and principle of master slave flip flop is that slave is always follows the master. Slave is always follows the master in the next coming cycle. Hmm. We can see the master flip flop is a combination of two clock RS flip flop feeded back from the output of the second to the input of the first. The first flip flop is called as be known as a master flip flop and the other is known as a slave. The master flip flop will act on the positive edge of the clock while slave flip flop is negative edge triggered. Hence, the master responds to the JK input before the slave. That is that slave will always follows the master. Now, the truth table is like this. When the clock appears, if there is j equal to 0, k equal to 0, and the previous state output were 0 and 1, the master will respond with the no change condition as 0 1, which will followed by slave, which is followed by slave when the clock appear as a negative clock for the slave. Okay, and you can see within this two tab this is followed by the slave. And if the output is 1 0, if the output is 1 0, is still again the master will provide no change condition. Whatever the previous input will be followed in the present input, and that is been latched for the second clock of the negative cycle. Now, similar way, if j is 0, k is 1, master's clock appear at the positive clock cycle. Present state is still, let's suppose the output was 0 and 1. The slave master will latch the 0 and 1 as a reset condition. Since j is 0 and k is 1, the reset condition that has been followed by the slave. Even if the previous input was 1 and 0, the slave master will make sure the output is 0 and 1 since the input is j equal to 0 and k equal to 1. K equal to 1, that means reset condition for the JK flip-flop of master side, that will be followed by the slave state. Now, if suppose that j is 1 and k is 0, when the clock positive clock will appear, master will make the output to be appear as a set, that is q is 1 and q bar is 0, and that has been followed by slave flip flop also. Now, if clock is appear previous input though it was 1 0, the master still make the output as a set output, and that has been followed by the slave. You can observe that every time slave follows in a next negative cycle, whereas master give the output at the positive cycle of the clock. With this, the flip-flop chapter has been finished.